All right, guys, this video, we're just going to do a real brief introduction of what's called composition of functions. If you look, you can even you can stop down or pause the video and just take notes off of this. Okay, if you ever see f of g of x, okay, this is how it's written, f of g of x. If the order is switched around, okay, this g of f, then you follow the same order, and it's g of f of x. Okay, the other thing you can take down is this as well. Whenever you find the domain of composition of functions, it's the intersection of the domains of f of x and g of x. All right, so take that down. Really, it's just whatever is common for the domain for f of x and g of x you use for the composition of the functions. Easy way, it kind of looks difficult, but it's really not too bad. All you're basically doing is whatever is written on the inside. So if you have f of g of x, you're taking this whole function g of x and plugging it into f. Here, you're going to do the opposite. Whatever's in here, you're taking this whole function of x and plugging it into the x for the g function. All right, let's look at an example. Once you see an example, it's not too bad. All right, here we have f of x is x plus 2, and g of x is 4 minus x squared. And we want to find this, f of g. So if I use this, I'm finding f of g of x. So you're just kind of substituting twice. So we're finding the function of this g of x, I replace with this, the 4 minus x squared. What this means is, since this g is written second, we're taking this whole function for g of x, which is this right here, and we're going to plug this into the x for f of x. So we're going to plug it right into here. So this x is going to change to 4 minus x squared. So when we do that, we're going to have 4 minus x squared, right? That replaces the x, and then we're going to add 2 to it. So then I'm going to put plus 2 right there. And then you just want to simplify. You're not solving for x, right? We don't have an equation. It's just an expression that we want to simplify. So now I can add the 4 and the 2, and I get 6 minus the x squared. Okay, if I move over to b, I'm going to do the opposite. I'm going to take the f of x and put it into the g of x. All right, so just move it here so I can still see f of x and g of x. So here we're finding g of the function of x. Well, function of x is this whole thing, x plus 2. So we're really finding g of x plus 2. This is just a fancy way of saying, all right, I'm going to take this x plus 2, and I'm going to plug it into g. So I'm going to take this x plus 2, and I'm going to plug it right into there for g of x. So I'm going to have 4 minus, and then I put in the x plus 2, and then it's squared, right? I put right in here this x plus 2, and I square it. So there it is, I square it. Now if I square that binomial, I'm going to get, what is it, minus, let's see here. If I square this, I get 3 terms. I get x squared. The product in here is 2x. If I double it, I get 4x. And then I square this, so 2 squared is 4. And then I just want to distribute the negative. Okay, I'm going to move over here so we have more space. So I'll put this right up here. So if I distribute this negative, I'm going to have 4 minus x squared minus 4x minus 4. Just combine your like terms. So then the 4's cancel, so we're left with negative x squared minus 4x. All right, so that gives us a brief introduction there of composition of functions. Basically, whatever function is written second, you take that entire expression and plug it into x for the other function there.